Hi there. So here we are in my office upstairs. The reason we're in my office is I need to do some Arduino testing. The reason I need to do the Arduino testing is because I want to create a speedometer on my layout. I've already gone ahead and bought one of the speedometers where you put it over top of the tracks and the train goes through there. So I want a permanent one. In order to get a permanent one, I decided to build one. I want to use an Arduino as my platform because it's a fun thing to do. And the other thing I found out online is here's an example of the IR detector I plan to use with a bulb, and I'm going to show you a simple sketch that you can take an Arduino, a bulb, and an IR detector. I don't have any resistors on this, so you run the risk of blowing a cheap LED out. But it's enough to do your initial testing to make sure this IR detector not only works, but set the distance as to what it's going to trip. So my goal here today is to show you this, and then I'm going to do a little bit of breadboarding with one of these guys. Right now it has a little push button. I don't know whether I'll incorporate that or not. And I'll set that up so that I have a couple of IR detectors in and pass my hand over and it'll flash some LEDs. Basically just doing prototyping so that I'm going to know how it's going to work. Later on we're going to go down to the train room and we're going to look at how we take these and put them underneath the track and then set up the wiring for them, set up the programming on the Arduino, and I still have to figure out what my display is going to be. I do have various choices. I can do like a 4-digit LED that just shows speed, or I can do something a little more than that with rolling numbers and messages going by. But it's got to be small because it's N scale, right? I haven't figured all that out, but let's get on and I can show you how this works. And this is thanks to looking stuff up on YouTube, and I can't remember the fellow's name that originally published this, but he did this exact thing. I copied that over, did a couple of extra changes, and what we end up with is this really nice, easy to test unit without taking a breadboard on it and hooking up a whole bunch of wires. So let's get started. Okay, here we are on my computer at a Google screen, and as I say, we want to be able to do this initial sketch for Arduino, and in order to do that I'm going to have to go find the movie, and I'm going to do a search on, here, let's go down here, IR. So now we're taking a video shot of that, and we'll move this over to here. What I have here is a USB extension, so it's on top here because everything else is underneath there on the computer. Now what we'll do here is grab my Arduino, and as per the video you'll be able to see that this is in ground and pin 11, and this is in pins A0, A1, A2, which have been remapped based upon the sketch you saw. Now all I have to do is take this and plug it into the USB port. It's not tough at all. Make sure I got the orientation right. Okay, and if you look on here, you can see that it's on, and this guy is being supplied with power, but he doesn't have that light on, indicating there's no reflection. So now what we do is come over to the screen here and make sure you can see it. We'll click on Tools, and we'll click on, got the right board, port, we'll select the COM5 port, and we'll go ahead and we'll do an upload. And it says uploading, done uploading, which means it should now be here. So let's see what happens as we move something over here. Oh, it detects. You can see it flashes the light as soon as it does. It detects. Now if I'm out here, you can see from a range perspective nothing's happening here. As I get in closer, at that point it's pretty reliable. That's about what I want for a train. So this simple sketch and setup of a board is enough to test this out. And if you have multiple detectors, you can take them, and I'll grab another one here that I have. Pull that out. We'll put this one in, and you can see the little pot on here, but there's about the right range again. So by turning that pot, you'll find that you can get that range. When I'm on the train layout, it's going to come in about this close, right? It's going to be really close. So I want to pick that up, but I don't want somebody going over the layout like this to set it off. So if I could, I'd put it down to there, but it's kind of, the potentiometer is a bit touchy, so I'm okay with doing it there, because that's only like a little more than an inch. Now I'm going to do some more. So this is what I wanted to test and see. This is a servo wire. Now what I've done with this one is I've cut the end. I'll grab my other, now I can't find my other servo wire, but oh, here it is. Normally the end looks like this, and it's set up like that so these guys can connect together. I'm not sure how this comes off, but I use these to get it off. The point being, this will connect in like that. So now I've got a nice easy connection here, and these guys will hopefully connect into the breadboard like that, and they do. So for a breadboard connection that I want to test, this is easy enough to do. And for actual installation, options are numerous. I can run this, I have extensions for servo cables I can run wherever I want. I could cut this guy off and wire it to a terminal harness. There's all sorts of things I could do. But for the testing that I want to do right now, I'm just going to use this setup. And all I'll do here is go in and put those in and go clip. Put it in the other side. Go clip. Bend this back. In this case, when I bend it back, it cracked a little further right along here. So I'll just take this in here and go clip and cut it the rest of the way. And I should be able to pop that out like that. There. It's a much better job. I got that one whole without taking part of the side off. So this is how I program. I took the sketch here that we had and I modified it. Now all of this is commented out. I now have two inputs, one for each of the sensors. I have three outputs, one for a green LED, a yellow, and a blue. And the code here goes through and it turns on the green one and then off, and the yellow one and then off, and then the blue one, and it's on for a second, and then I turn them all on for 2 seconds, and after turning them on for 2 seconds I turn them all on for 1 second, then I turn them off for 2 seconds, and then just loop through, and this is what you end up with. And we're just partway through the cycle. All off, green on, yellow on, blue on, all on, and then all off. I found this to be an effective way of coding. You code a little bit, you test it out, make sure it works, code a little bit more, test it out, make sure it works. Now when I first started coding in the late 60s, so yeah, it's been that long, it turns out to be 50 years. Anyway, in the late 60s, you had to write your entire program, check it, went off to be card punched and compiled, took a couple of days. So you wrote everything. You didn't have this opportunity. All this prototyping it makes a big difference, makes it a lot nicer these days. So the next iteration is pretty simple. I just read the pin from the IR device, and if there's something in the way, I do a write high, otherwise a write low to the two LEDs. So what you can see here is downloaded the sketch, nothing's on. I'll take something like this here, and you can see as I go across, it lights that one. And there it goes. Could be the surface. That surface is okay. It's fine with that. I'll have to check that and see, because the testing I was doing earlier was with this piece of white card, and of course that works. It's nice and reflective. But this, while it's black, it's not till it gets this part here of my hand that it reflects. So if you go like this, sometimes it does, sometimes it doesn't. This one's, yeah, it works all the time. This one, oh. The other interesting thing I found here is if you look really closely, this detector detects at that point. So it's just over the black emitter. Coming this way, it detects right there. It's over the white emitter. So there's a gap between there and there, which will be from about there to there. So there's a couple of millimeter gap in there. Because I'm using this as a speedometer, I have to know the exact distance between when it will and won't trip. And so I either have to arrange it so that that always trips at the same point by maybe bending these or something, or I have to know which direction the train's going to figure out what the calculation is going to be and do a different calculation in each direction. So that's another interesting little tidbit. But now what I've done is I know how to wire the LEDs in, I know how to, these IRs will work pretty much. I got to figure out why they don't reflect on black. I now have to get them downstairs into my track down there and see if the overhead lighting does anything with them or not, and make sure that all still works. And that'll be up next.